today's edition of Cracking the Cryptic, where we have a puzzle for you today by one of the most popular constructors in the whole world, and that is zetamath, and a puzzle called Zag. Now, when I saw that this was being suggested for me today, I was a bit confused because I thought I'd done a puzzle called something like Zag by zetamath before. I had a quick look at zetamath's back catalogue, and I checked our back catalogue as well, and I'm sure I haven't done this. It's just ringing a weird bell with me. So anyway, this is what I'm going to be doing. It's basically a 10 lines puzzle. This orange thing here is a 10 line. So if you're familiar with 10 lines in sudoku, you will know how this works. And there's some arrows as well, but nothing more complicated than that. 3 stars out of 5 for difficulty on Logic Masters Germany, and the usual 95 or something % approval rating that you'd expect from every single puzzle by the great man. So this is what we're going to be doing in today's video, after I have told you about a couple of exciting things. I'll start off with a picture that I took last night. Here you go. I hope you can see that. That is taken from my house last night. Can you believe it? The Northern Lights made an appearance in Surrey. A few years ago, I went on a special trip to Lapland with the express sort of purpose of seeing the Northern Lights, and no Northern Lights were to be seen on that trip, which was a great disappointment. So I can't tell you how extraordinary it was. I nearly missed them as well. There wasn't sort of a big hoo-ha here in the UK about them being there last night, but I was about to go to bed. I looked at Twitter and hashtag Aurora was trending. I thought, why is hashtag Aurora trending? And Brian Cox, the sort of physicist stroke rock star, had tweeted some of his own pictures from Surrey. So I immediately went outside, and there we go. So, and apparently it might happen again tonight. So I'm definitely going to have a look outside. And thanks also to Peg, who also dropped me an email telling me this might happen. Yeah, so just blown away by that. And if I get any more good pictures, if you're following us on Twitter, I shall send them there later on tonight, at Cryptic Cracking, of course. Now, next, there's going to be a bonus video on the channel tomorrow. It's going to be a crossword video in which I solve a puzzle by the great and very funny Steve Pemberton. Now, some of you may know Steve from Inside Number 9. Amongst other things. I think Steve has been a writer on Doctor Who for years as well. And Steve was on Taskmaster, the quiz show, the other day, talking about something like things that... What is one thing that you would say people should get into? And Steve said, people should get into cryptic crosswords, and Steve is right. And to prove that point, Steve had actually set the Guardian cryptic crossword for that day, and sort of encouraged the audience to have a go at it. And I had a go at it, and I can tell you it is spectacularly good. It also contains some extra thematic material that I discovered at the end of the solve, and it is yeah, it's just tremendous. So if you have any interest in cryptic crosswords at all, check that video out. That will come out tomorrow morning on the channel, UK time, 10 o'clock, I hope, providing I've done the editing by then, which I fully intend to have done. Other things to talk about. We've got all our stuff going on over on Patreon, the Glum Hippo Sudoku Hunt. Do have a look at that. But also some birthdays to do today. So let's say happy birthday to Amy from your fiance, Akos. I know the two of you are getting married in August, so not long now. And down there in Sydney, Australia, I think. And apparently you enjoy watching the channel to relax after a day of stressful wedding preparation. So thank you for watching, and Amy, many happy returns. Next to Kevin, who's turned 53 today, and I remember you, Kevin, from last year because you live in Gun Barrel City, and I couldn't believe there was a place called Gun Barrel City, but there is, and Kevin lives there. And Kevin, many happy returns. Thank you for watching the channel. Next, Rochelle. I hope I'm saying your name correctly, Rochelle. You've turned 22 today, and I know this because your partner Kyra wrote to us I think you're over there in the Netherlands, if I'm not mistaken, and I am told you are getting white chocolate cake today. Now that could be spectacularly good. That really could. Send me a picture if it is spectacularly good, just so that I can be jealous. And next, I'm going to say Veronica. I hope I'm saying your name correctly, Veronica. And you have turned 22 today. And I know this because your sister Aurelia wrote to us and said you'd appreciate the shout out. So many happy returns. I hope you get chocolate cake, white or dark chocolate cake or milk chocolate cake. All are fine, providing there's enough icing, of course. And the only other thing I wanted to say is to thank Rhett for sending us a kind email down there in Australia. Rhett, thank you very much. We did appreciate it. Now, let's turn our attention to solving some Sudoku and have a look at Zag by zetamath. These are the rules. Normal Sudoku rules apply. Digits along the orange line must be broken into one or more contiguous groups of cells that each sum to 10. Such groups cannot overlap. Digits may repeat within such sums if allowed by other rules. For example, 513 173 is a valid fill for a 6th length line because it can be broken up into 5131 and 73, each of which sum to 10. So let's stop there and make sure we understand how this line works. So basically we're going to have to divide it up into pieces. So let's just have a go. Oh, terrible choice of colour. So we could do something like this. This may well be right, because there aren't that many ways of filling 10 lines. So forgive me if this is right. But basically, if this was the correct way of splitting the line up, then those 3 would add up to 10, these 2 would add up to 10, these 2 would add up to 10, those 4 would add up to 10, these 3 would add up to 10, etc., etc. So basically, it's a very natural rule, but it's really easy, in my experience at least, to make mistakes, especially when you forget about the possibility of things being repeated on the line. So if you look at that little section there, that looks like it's absolutely waiting for me to fall into a trap, because it might be possible to have sort of 2 repeats on the line and create all sorts of weird concoctions that actually add up to 10. There's only one more rule, which is that digits along an arrow sum to the digit in that arrow circle. So those 3 digits there, you add them up and you put the result in that circle. It's as simple as that. So let's do an example. If that was 1, 2 and 3, 1 plus 2 plus 3 equals 6. That's a slip of the finger, not a slip of the mind yet. And that is how arrows work. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, I'm going to take the low-hanging fruit, Sata. I'm sorry, I am. So normally I would start by trying to divide the line. But actually, I think I'm going to start with the arrows here. Because 3-cell arrows are interesting if the digits on the arrow all have to be different. Because these have to be at least 1, 2 and 3. Which means that square is at least 6. There might be some maths we can do actually with box 1. We'll come back to that. That one's got to be at least 6 as well. That's 3 different digits. Okay, I can't do more than that. But the reason I'm thinking about maths is because of a secret. And it's a secret I share with only my very favourite people. But if you're watching this video, you're definitely one of my favourite people. So I'm very happy to share the secret. And the secret is to do with the sum of any complete row, any complete column, or indeed any complete box of a Sudoku. Now, because we know this box contains the digits 1 to 9 once each, because of the rules of Sudoku, we know those digits sum to 45. Now, my first thought there is that 45 is an odd number. Knowledge bomb. Whereas the contents of this arrow are going to be in total even. And the way we can see that is, of course, we know those, let's say these 3 digits sum to x. Then we're going to write x in the circle, aren't we? In other words, the total contents of those 4 cells sum to 2x, and 2x must be an even number. Now, given that 45 is odd, we now know these digits sum to an odd number, which means that they don't exactly divide into 10 lines. So it's not going to be the case, we can say now, for example, that we're splitting that line up into 2 segments like that, each of which adds up to 10, because that would make maths wrong, and maths, in my experience at least, tends to be right. So what that means is, well, okay, I now see what that means, because we can now think about how many different 10 sums we have to put into these 5 cells. And we've basically got a very narrow choice, given that, well, one secret of 10 sums, and it's a bit fatuous, but I'll say it, is that any 10 sum must be at least a 2-cell sequence, because you can't just write 10 into a single cell. Oh, somebody's going very fast. So, the choices for how we're going to divide up this line are broadly, we could have one 10 sum, couldn't we? And then 2 digits that would add up to a maximum of 9. So that would be something like 19 there. And that can't be right, because the maximum size of this digit is 9, which means the maximum size of those 4 cells is 18, which means the minimum size of these cells is 27. And therefore I must be getting at least 2 full 10 sums in here, because otherwise numbers won't work again, will they? We're going to inflate that too high. So in fact, what we can say is that this line must be broken up into 2 10 sums, 2 complete 10 sums, some rump as the remainder, and that even the remaining rump is going to have to be fairly substantial. Yeah, so if those sums sum to 20, which they do, and then we add 9 on here, plus another 9 there, that's giving us 38, which makes this 7. But the interesting thing about that is that if I reduce this by just 1 and make it 8, then I'm increasing this by 2 effectively, because I'm increasing it by 1 for the circle and 1 for the arrow. So that is 7 or 9, and this is 8 or 9. Ah, so there is a 9 in one of these squares. That's the sort of zeta deduction that might matter. So it's either 9, 7 or it's 9, 8 in the other order. Now, okay, so now I'll tell you my next thought. My next thought is about 5 in this box, because these are 2-cell 10 sequences. So if we were to put 5 into either of these dominoes, the other digit to add up to 10 would have to be 5 again, wouldn't it? And that means 5 is on the arrow. Now if 5 is on the arrow and this is 8, this is a 1-2 pair that goes with the 5. So we get 8, 9. I'm almost sure that's going to be correct. The reason I really like the look of that is it would use 8 and 9 here, and their complements, if you like, in terms of dominoage that adds up to 10 are 1 and 2. So having 1 and 2 on the arrow is exactly where they should be, because they can't be in here. So the other option is that this is 9, and then if this is 9, we worked out that was 7, didn't we? Okay, but this would be... Oh, no, that's fine as well. That's weird. Okay, that's also fine. I wasn't expecting that. Because if this is 9, and we've got to have 5 on the arrow, it must be 1, 3, 5. And that means you have a 3 on this arrow, which is the complement of the 7 that would go there. So you'd have 1 and 3, which are the complements of 7 and 9, and this would be fine again. That's really strange. Okay. I don't know if I'm meant to do this, but I'm going to do it. That's definitely... These cells are definitely from here, and there's definitely a 1 on this arrow. Whether this is 8 or 9. So... Good grief. Okay, so it's right. It's this digit that we have to focus on. That's very clever. Good grief. Right. This is not 9. And this is not 9 for, it's not even that easy a reason, but it's very beautiful. This is not 9 because what would happen if it is? And we have to look at this box to see that there's a problem. So maybe this is a sort of good Agad Mator moment, the sort of chess YouTuber who often says, pause the video, I'll give you a couple of seconds to see what's what if you want to spot the next move in a complicated chess game. Well, here, can you spot why this can't be a 9? For those of you who managed to do it, congratulations. The reason's really clever, because if this is 9, this has to be 1 to make a 10 sum. But look at this arrow now. How's that going to work? It can't have a 1 on it and it's 3 cells long, so it would have to be 2, 3 and 4, and then this would be a 9. That's the only way it could possibly be constituted. But now we have a big problem on the orange line, because we've got to make some number of digits here add up to 10. And we can't use 1, 2, 3 and 4 because they've disappeared from the box. So this is at least a 5 and this is at least a 6 then. So those are adding up to at least 11, and there's no 10 sum possible. That's just lovely. That's just lovely, isn't it? So that's giving us this digit. Well, not really giving it to us, but it's helping us this digit. Now, my first opportunity for a mistake I have just avoided. I was about to say this is a 3, but it's not, is it? Because this could be a 1-2 pair adding to 3. So, ooh. Okay, so that digit is 1, 2 or 3, but we have to be careful because this could extend. In fact, I'll start colouring it, but that one might be purple. There's probably something we can do on that arrow now, but let's go back to this box because when that was 7 by mathematics, this was 9, which means there is no 2 on this arrow. So we've now got even digits in the dominoes, so 2 8s and 4 6s. So if this was a 2, this would be 2 8, this would be 4 6. That's probably okay. Okay, simple point. That can't be 6, because a 6 arrow would involve this being a 1, 2, 3 triple, thereby effectively making this cell impossible to fill. So that is now at least 7. But all of the... If we think about a 3-cell arrow, even if this is 9, this arrow must have 2 of the digits 1, 2 and 3 on it. Because let's imagine it didn't. If it only has 1 of the digits 1, 2 and 3 on it, then its minimum constituents would be a 1 and a 4 and a 5, and 1 plus 4 plus 5 is 10. So that doesn't work. So this collection of 4 digits contains all of the digits 1, 2 and 3, which I feel is somehow meant to be point. Well, yes, that is the point. Okay, so that's also telling me the nature of this digit, because if this was a 1, 2 pair, then the minimum constituents of this arrow would be 3, 4, 5, and that's too many, isn't it? So this is 3, and it didn't extend here. And okay, so right, so now I'm going to use the fact this can't be 7, because if this was 7, this arrow would be 1, 2 and 4, and we'd run into exactly the same problem we were going to run into before when this was 9, because if this was 1, 2, 4, then these two squares again have to be at least a 5, 6 pair, and that's too many, so that's not 7. So now it's either 8, and if it's 8, then it can't have 3 on it, so it's going to have to be 1, 2 and 5. Oh, but that looks likely, doesn't it? Because then this could be 4, 6 and work. Don't know. Okay, but that's if that's 8. If this is 9, it's also very restricted, because then it can't have 3 on its arrow. So it's not 2, 3, 4, and it's not 1, 3, 5. So it's going to be 1, 2, 6. Right, so this arrow always has 1 and 2 on it. So now this is there any way that this... I feel like that's got to be... Oh no, I'm wrong. Gosh, that was almost a sixth sense there. I was like, this has got to be 4, 6, doesn't it? But actually that's not true. It could be 4, 5. I mean, there must be a 4 in one of those squares. That's definitely true. Because if there wasn't, the minimum digits we could put in would be 5, because 1, 2, and 3 have been hypothecated to these 4 squares. And we couldn't put 6 in then. It wouldn't matter. 5 and 6 is too big anyway, but the minimum sum of these would be too big anyway. Alright, so this is either 4, 6 or it's 4, 5, but we don't know whether this one is included or not. At least I don't think we do. There might be a reason we do, but I am not seeing it. So if that's 4, 6... Oh no, it's much simpler than that. It's Sudoku. How embarrassing! never one to overdo the Sudoku. Right, okay. Where does 9 go in box 2? That's a legitimate question. One could have asked probably about 25 minutes ago. I didn't see it. There we go. It goes there, and therefore I've got, well, now 6. Right. Okay. So 6 has been removed from this domino. So this is 4, 5, that is 1. So that's a little sequence. These squares are, okay, there's 7 and 8. Now, 8 comes out of there, so 2 comes out of here. 9 lives in one of 2 places in box 3. It can't go on the arrow, because this, if it's on the arrow, this is at least a 10, and that is not possible in this puzzle. Now, the other thing I was looking at was this. Because we know that's a sequence, we can't join these 2 together. They add up to 15. So this domino here is a 10 sum, definitely. Let's make it a different colour. So this square here is a 2 or a 3. Yeah, and then again, we've got to be careful with this digit. Because if that's an 8, then that is a 2. But if that's a 7... this could be a 3, or if this is a 7, that could be a 1, 2 pair. So that digit is, I don't think, known to us. Or to put it a different way, we don't even know the length of this 10 sum. Let's use grey. It could go here, so we've got to be careful. Right. Now, what have you done now, zetamath? What have you done now? What do I do? Maverick is about to fly past. There were loads of planes in the air last night as well. I presume that that's people who knew that the aurora was there, and they were going to see it from the sky. Okay. I don't know what to do. Sorry, if this is obvious, I apologise. I'm not seeing anything. I don't know. I was going to say I think it might be this box, but I really am not sure. If this is a 1, 2 pair, does that give... No, that doesn't give me a problem on the arrow. This arrow is a minutely restricted. Oh, good grief. Right. No, it isn't actually. That's vicious. That is vicious. zetamath. That. I feel quite lucky to have seen this. Because I only saw this because I was thinking about the fact that 1 couldn't be on there. I can see very clearly that 1 isn't on this arrow. And I had the thought, okay, if that's a 2, 2 can't be on it. And that struck me as a little bit interesting, because then I could see that this was 6 or 8. Because if this is 2, both of those digits can't be 1 or 2. Therefore, they could be double 3, was my thought. So I was thinking 6 or 8. And then I thought, oh no, double 3 won't work because of that. But then I realised, oh well, hang on, I've also got a 4-5 pair looking at this. So that digit, all of a sudden, if this is 2, this becomes at least 6, and that becomes at least 3, and that becomes at least 9, and it can't be 9. That actually is beautiful setting, because that, I cannot tell you how unrestricted a 2-cell arrow normally is when these 2 digits on the arrow don't see each other. So you can't even say they have to be different. That is weird. And it's a beautiful idea though, isn't it? I'm just trying to think about that from a setter's perspective. So zetamath has noticed the possibility that if this is 2, these 2 digits are under significant upward pressure. And then notice this digit would also be under that pressure. Once you have the idea, you can't leave it. You can't not do that. But having the idea is the genius. That's lovely. It's just lovely. Right, and what does it mean? Well, it means this isn't 2, so that's 3. It's probably not going to do very much, but it's... Well, no, it has done something. Because now we can't. This cannot extend, because we need 2 more. And we can't split that up into double 1 along this naughty line. So, now... Well, now what do we do? What's that actually done? Yeah, there. That's what it's done. It's got rid of 2 and 8 from this. So this is now... whoopsie. No. That's the 2-8 pair. That's great. Right, so that gets me a 2 here and a 1-6 pair. These squares are now 4, 5 and 9. Can't put 9 in the thingy. Actually, I've seen what that's done as well. That's beautiful. I'll come back to that in a second. Let me just do sudoku a bit more. Or not. No, I'm not. I'm so appallingly bad sometimes. There must be something going on here. I can't see what it is, so I'm going to do what I saw up here. If this is 9, what's this digit? And because this is 4, 5, that also would have to be a 4, 5, wouldn't it? But we know there's a 4, 5 pair in these squares, so we can't. This cannot be a 4, 5 arrow, so that cannot be 9. And that's actually really good, because that's going now, by sort of arrow logic, we must have the higher digit. So that must be must do that by maths. Now that's good, because that gives me another digit here, and that gives me a digit here, digit here, digit here, digit here. Here we go. Right, this is a 7, 8 pair now. These digits are a 3, 6 pair. So we'll have a look at this 10 sum in a moment, but let me just see if we can do anything else that's more straightforward. I can see something here as well. And may even be so. There's a few things to look at now. I'm not sure which is the one that's the most urgent. Let's try this one first, I think. So let's join those up together. Oh, that's a horrible choice. We'll go back to green maybe. Now obviously this might be many cells long, although it probably can't be that long because 1 and 3. No, yeah, given actually that we can't put 1 in this sequence, this is either a 2 cell or a 3 cell. That's all it could be. But it could be 3, 2, 5, couldn't it? So I think it's definitely got the possibility of being a 3 cell sequence. Yeah, it's under more pressure if this is 6, because if this is 6, this has to be 4, because 1 and 3 are not available to make the extra 4 up because of this. So if that's 6, this is 4. If it's 3, well, 7 would work straight away in a domino, but it could extend. So if these two digits had to add up to 7 to make the extra 10, or to make the 10 total if this is 3, we couldn't be 1, 6 or 3, 4ing, so we'd have to be 2, 5ing, and it would have to be 2 here by sudoku. Okay, alright, I'm now fairly convinced this wasn't what I was meant to do next, because that doesn't feel like it's under enough pressure. Okay, I'm just going to talk about the thing I noticed here, which is this. Because 1 is not available, that clearly is not a 4-cell sequence summing to 10, because the only 4-cell sequence that can work if the digits see each other is 1, 2, 3 and 4. Now, it can't be a 3-cell sequence either, for an interesting reason, which is that the only 3-cell sequence that does add up to 10, if you can't use a 1, is 2, 3, 5. And that will break that square. So this feels like a zetamath thing. Because what we're now learning is that is a domino that adds up to 10, and it's not 1, 9, and it's not 2, 8. So this is either 3, 7 or 4, 6. Now, can we do better than that? And the answer is no. No is the answer. Although, if that's 4, 6 and that's 4, 6, 4s and 6s would be down there. Oh, but it's sort of symmetrical, isn't it? If that's 3, 7, then that's 3, 7, and we get 3 7s down there. So whatever this is, it has quite a lot of effect on box 7. Okay, let's try this little arrow then. But the thing is, it's weird. The availability now of 2. You see, 2 can go in both those positions, so this can be pretty minute. So we can have double 2 equals 4. If we don't have, well, we can't not have 2 on the arrow. We've already worked that out. So 2 is in one of those squares. That feels like a point. 2 is in at least one of those squares. No. The places that feels like it's operating on this cell the most. I'm just going to notate that square. That square is 4, 5, 6 or 7 by sudoku then. Because whichever one of these is 2, they might both be 2, but it doesn't matter. Which one of these is 2, and that's seeing that square. This already sees a 1, 3 pair, and it sees an 8, 9 pair, so that's quite big. If that's not 2, it is whopping then, because it's at least 6. So that would push this. That in fact, okay. So if that isn't 2, if this digit is not 2, what could it possibly be? And because it can't be 3, 4, or 5, it's actually got to be 6. And that's because this can't be 1. Because if we push this up to 7, we know this is at least 2, and that's going to make this at least 9, which it can't be. So that digit is restricted. It's only 2 or 6. And if it's 6, this is 2. But if this is 2, then I think all bets are off. This can't be 3, so it would be a 4. Oh, hang on, that can't be 7 either. Yeah, I'm probably going to just list out the options for this because it's intriguing me, and I can't quite see how this is how few digits this can be. So if this is 6, we know this is 2, this is 8. If this is 2, this could be 4, I think, which would make that 6. If it's not 4, it can't be 5, because that would make this 7, which it can't be. So it's going up to 6 again, which is the most it could be, because we can't make this bigger than 8. Oh, for goodness sake. For goodness sake, that is beautiful. Right. Okay. I can see something very, very simple there then that just kills this. Again, it is an Agadmeta moment. This is so beautiful though. This is so... I want to say simple, but that doesn't do it justice because it's not... It is simple, and when I tell you what it is, if you haven't seen it, you will go, oh, of course. But it's just beautiful. It's so elegant. In fact, I will tell you this for nothing. This tiny little arrow here and this tiny little arrow here are doing ethereal work in terms of this Sudoku. Because, now I'm going to tell you, this is not 4-6. Because if this is 4-6, those two digits, I haven't worked out whether they even work, but I can see they're both even. And if they're both even, all the even digits have gone from this box. How on earth can you make this work? That's 3 odd digits, but 2 of them are being added up. So that's got to be even, and it can't be. There's no way you can constitute a 3-cell arrow with only odd digits. It won't work. So I think it's parity that's telling us that this is 3-7. Right, and look, that's doing work. So now we know 3 and 7 are down here. We're heading for 3 in the corner. Oh golly, what does that mean? 9 is a bit restricted in this box because it can go in this. It can't go on an arrow, so it's in one of 2 places. It might be. Is it this continuation or not? This might well benefit from some thought. Let's think about that. If this is a 2-cell sequence, it can't be 1, 9, 2, 8, 3, or 3, 7. So it is 4, 6. Now, why is that a problem? I don't know. But if this is a 3-cell sequence, I mean, it might even be able to be a 4-cell sequence because these two can be different. The minimum sum of these is, I suppose this is a minimum sum of 2 and 4, isn't it? Which would be 6. But that could be a 1. Oh, and then we get, and that could be a 2. Yeah. Oh, good grief. Oh, no, that I was thinking maybe even we could extend and become a 5-cell sequence. No, but we can't do that because that really will break these two squares. So 2, 4, 1. Now, it's a bit weird because there might be a restriction here from the point of view that you can't increase any one of the... Oh, you can't increase any of the digits by exactly 1, which is what I'm trying to do to make it work. I mean, I think if it does go there, that has to be a 2. I'm very sure about that, which would mean these 3 squares have to add up to 8. Which means one of them has to be a 1, which has to be this one, which means this has to be 2, 4. Sorry, that doesn't work, does it? Not 2, 4, because they don't add up to 8. In fact, there's no way to make those 2 squares add up to 7. That's weird. So, okay, so it's not a 4-cell sequence. So, is it a 3-cell sequence? Because otherwise it's 4, 6. Could it be a 3-cell sequence? But the thing about a 3-cell sequence is that can be 1 or 2. So, what could we have there? We can't have 2, 7. So we can't, these 2 can't add up to 9, because 1, 8, 2, 7, 3, 6, and 4, 5 are unavailable. So, this would be 2. These, see, I just don't think this works. I think this might have to be 4, 6. But I'm sort of terrified that I'm missing a point here. Again, I feel a bit like, where was it? I can't remember. There was somewhere up there where I felt like I was making a mistake. And I feel like I'm making a mistake, even though I think the logic is telling me that this is 4, 6. I don't know. I don't know. I'm going to have a look. I'm going to have a look at... Is there something else that's easier? Is that become easier now? No. No, that's nonsense. These 2s, I was just wondering if I could... That can't be a 2, but this could be a 1. Yeah, okay, that circle is being pushed up a bit. Not much, but it can't be a low number, I don't think. Because the lowest this could be would be 3. 3 won't work. This can't be a 1, 2 pair. It can't be 4 because this can't be a 1, 3 pair. It can't be 5 by sudoku. Now, could it be 6? Only just. It could be 6 if this was 1 and this was 5. That's just possible. Perhaps. It can't be 7. Now, if it's 8, what happens then? Because if it's 8, 3, 5, and 1, 7 go away. So if it's 8, this is 2, 6, and that doesn't work. Right, it's not 8. So can it be 9? I've got 9 pencil marked in here, but I think that was Sudoku. I don't think I thought about the arrow. Now, if it's 9, this has to be 1, 8. It has to be 1, 8. Right, so that's always 1. There you go. That's a deduction. That is always 1. And this is either an 8, 9 pair or a 5, 6 pair. 5, 6. No, that's still okay. I've got it. Right, beautiful. That is not a 5, 6 pair. Okay, and this is okay. I'm more comfortable with this deduction than I was down here. I might turn out to be right down here, but I felt worried about it. Now look, if this is 5, 6, where do you put 8 and 9 in this row? And the answer to that is it's tricky. You can put one of them here, but one of them has to go there. And I don't think that can be an 8 or a 9. Because what am I going to join it to? I can't join it to this, that's far too large. And I can't join it to that, because that's part of this domino and adds up to at least 5. So there's no way that works. So this must be the 8 and the 9. That's at least a thing we have discovered. Now that being 8 means that's 6, which means that can't be 6 as well, doesn't it? So that's now 2, that's 4 by mathematics. That's 8, that's 2. This might do it. I shouldn't have said that. I don't know why I said that. Yeah, now I've made a mistake. Sorry. Oh, that's so ironic. And so I so deserved that. Oh, hang on, look at that. I've seen a way that this can be a 4. Like, why can't that be double 2? Did I use that for anything? No, but I've got lucky there. Well, I did use it a bit, because when I said if this was 4, 6, these were both even, and I'd have used all the even digits, that still would have been true if I'd written 4 in there, wouldn't it? But I got lucky because I didn't see. I think I did see the possibility of that being double 2 at one point, but I didn't pencil mark it properly. So, but this is good. It's good because now if that's because the puzzle might still work. This is why it's good. So that's 8. That's 2. Now, are we saying basically that by hook or by crook we have proved this is a 4? I think we probably are, but let's see if we can do it in an elegant way. If this is 6, that has to be 2, that has to be 4, and there's nowhere for 2 in the box. That is quite elegant. I quite like that. So I don't see what's wrong with that. I think that is potentially exactly what zetamath intended. So now this has to be double 2 by mathematics. So that is not 2. That's probably going to do something to that domino. These squares are 5 and 6. Oh, we can do it. That's a 6. That's a 5. So now what's down here? 3, 7 and 9. And what's down here? 2, 4 and 6. Yeah, this is looking like it's going to be a 4, 6 pair, isn't it? And this down here is 1, 8 and 5. Oh, and look down here. In this column, I've got all the low numbers now, so these are all massive numbers, right? So what we should do is work, but these two can't join together because they would add up to more than 10. So this one has to go backwards along the line, and it can't join up with 8 or 5, can it? Because it's going to break the 10 boundary. So that has to be a 1. I don't know whether it joins here or not, but it definitely. Yeah, no. This has cleared up all of the potential confusion in this part of the grid, because we can't extend this any further. We know that this is at least a 2-cell sum, but we know those two are sort of tied together by an indelible ligature. So given these two are tied together and the sum of those is at least 7, and these two are tied together and the sum of those is at least 6, they have to live independently from one another. So that's got to be 9. This is a 4, 6 pair. This is, I didn't work out before that's a 2, but that's what it turns out to be. So these digits now are all smaller than they once could have been. That's not a 9. And we can, well, that digit's got to join up with something here that can't be too big. So that's 1 or 4 only, because it can't be 2 or 3. But be careful, because we could be going here as well, couldn't we? If this was, say, 613 or 712, no, 712 wouldn't work. Oh, in fact, that's weird. So that can't be 7, can it? Because if that's 7, what on earth do we pair it up with? We'd have to pair it up with 1 and then 2, and we can't, so that's not 7. So this is even. Oh, much simpler. This can't be 8, because 8 would need a 2. This is a 6. That's so weird. Okay. Oh, goodness. All right, so that's good. Don't know what it means, but it's good. I still don't know whether this goes to be 3 cells or it just sticks being 2. Have we resolved this now? We need. Yeah, all of this is biggish now, isn't it? 4, 5, 6, and 7. Okay, so we know those two add up to at least 7 on their own, so we can't join it to this one. That cannot work, can it? Because it would add up to at least 11. So these have to live independently. Oh no! So they're either 3, 7 or they're 6, 4. Both of which seem to be entirely possible. Ah. Oh, but that's gorgeous, actually. If this was a 4, if this was 6, 4, this domino couldn't work, because these digits would then be at least 5 plus 6. Oh, that's lovely. So we've got to go the other way. That's got to be 3, that's got to be 7. Oh, and now these can just live together in harmony, can't they? They could just be a 4, 6 pair. In fact, they probably have to be a 4, 6 pair, because that digit's too big. If this is a 3-cell sequence, this is at least a 4. Yeah, there you go. So they have to be a 4, 6 pair. This has to be a 5. 7 and 8 get filled by sudoku. This is a sequence. Make it blue. No, I'm going to make it yellow. So this one is, well, these two are together with possibly more, but don't know. Oh, no, I do know. I do know. Look at this domino, because it's very pretty. This can't be a domino, because there is no 10 fill that works. 1, 9, 2, 8, 3, 7 would kill that one, and 4, 6 doesn't work. So it's at least a 3-celler. Now, if it was a 4-celler, can it really be a 4-celler? No, because this is too big. If it's a 4-celler, this is at least 4, and these squares can't include 2, so they would be a minimum of 1, 3, 4. So we'd be adding 8 to 4, and we're getting more than 10, aren't we? So we actually know the length of this, and we know that it's not got a 2 in it. So, do we know it's got a 1 in it, is the natural question. Well, we do, but you have to be a bit careful with that. It has got a 1 in it, and that 1 is here, because if it didn't, how could it work? If it's not got 1s or 2s in it, the minimum digits are 3s and 4s and 5s. Well, they can't all be different, because 3, 4, 5 adds up to 12. So you'd have to repeat a digit. Now you can't repeat the 4 because double 4, 3 adds up to 11. But you could repeat the 3 with double 3, 4, except that's going to break those squares. And also that one, I now notice. Right, so this has got a 1 in it, and by sudoku that's here. So these two add up to 9, and they are not 1, 8, 2, 7, or 3, 6. So they are, oh weird, they're 4, 5. And we know the order. Okay, well that's something. This is a beautiful puzzle, isn't it? It really is beautiful. Now, where's 7 in box 5? And the answer is I don't quite know. But it's in one of those squares. So that's fixing that as 7 and that as 3. So now there's a 3 by sudoku here. That's an 8 by sudoku. That's 2, that's 9. And we do that box without having to worry too much about it. Except I've made a mistake again, because now I can't put 3 in this row. What did I do? I've got 2 4s in this box. What nonsense have I propagated here? Sorry. How did I do that? In fact, that's a 6 I'm now seeing. I don't know what I did then, but whatever it was such utter nonsense. It didn't deserve your attention. Well, 3 in this. Oh, I might have tried to type 3 and typed 4 instead. That's possible, because I'm seeing 3 has to go there. That is still 8. Yeah, and these are... Well, these are 2 and 9. And now I have... Yeah, I think what I did was I misclicked this digit. I might be wrong. But that does seem to be what happened. So that's 9 and that's 6. That's 8 now. And we can do a bit more at the top of the grid. In this column, 1, 4 and 5 to go in. So we'll put the options in and see what we can do. And what about this? Oh, 2, 3 and 7. Oh no, that can still work. Oh, bobbins. Okay. So, all right. Well, it's going to be this little line segment, but I think we've got to go full ham on the pencil marking now. So 2, 7, 9 here. 1, 4, 6 here. Now, what's breaking? And these are 3, 5, and 8. With that not allowed to be 8. So, okay, this can't be 8, can it? Because it's going to join up with this digit and make more than 10. So that is a 3, 5 pair. 3 and 5 add up to 8. That's not 10. So we need 2 more. So that's a 2. That's a 7 now. So that's 7, 9, 2. Now that's 9 by sudoku. This is, oh, it's 7 in the corner. We didn't get a 3 in the corner. Now, is this... Oh, I've got a 4, 6 pair here, so this is 5. That's 7. That's 3. Oh, right. Yeah, okay. Because that was a sequence that added up to 10, let's make it green. This actually is now resolving. It has to be that way round to make the mathematics work. So we can finish off all of our 10 sums now, which we should do. I haven't been using orange, although on an orange line that's forgivable. Let's make that grey so that it doesn't clash. Right, there we go. So hopefully we're there. 5, 8, 8 here, 4 here, 6 here, 1, 4, 6 there. What a beautiful... Oh no, I messed it up. I've got 2 6s here. Is that just a slip of the... I've got 2 6s in this box. I will double check it because I don't like that. How? What have I done there? Look, I've gone there and then I've written 6 in there. Did I mean to write 7? I did mean to write 7. Oh dear, dear, dear. I'm so sorry. I've had a peculiar number of what feels like misprints or misclicks today, which is most distressing. 4, 6, 1, 6, 4, 8, 5, 8, tick. Phew. Gosh, nearly 200 people have done that. This has been out for a month, apparently. I didn't know about it. That's remiss of me. But that is a beautiful puzzle, my friend. As usual. You never let the community down, zetamath. You just produce stellar puzzle after stellar puzzle. And that puzzle, you know, 10 sums. We have done a lot of puzzles with 10 sums. You may think sort of 10 sums have been exhausted, but no, they haven't. That was lovely. And there were some moments of absolute sublime brilliance. My favourite actually was these 2 arrows. They are the most ridiculously beautiful. This one and the parity point was sensational, and the fact that this existed at all was sensational because it had no right to. It had no right that this arrow helped with this digit, and yet it did. Yeah, that's brilliant. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind. And we'll be back later with another edition of Cracking the Cryptic.